Hi, Mr. Minnick here, helping my students with this enhanced for loop worksheet. Um, these are all examples of for each loops, also known as enhanced for loops, and they have a colon instead of semicolons and the traditional I++ step expression. So let's proceed. In exercise 1, we have a one-dimensional array here. Sum is equal to 0, and we hit the for loop. Next score is being declared as a variable here, as an int. I could have named this anything I wanted, like x or num or even I, though that would be a bad style. So I named my variable next score. So into that variable, each of these numbers here, one by one, will be placed into the variable next score. And the name of the array that we're going through here is typed after the colon. So the way this works is the first time through the loop, next score is 89. 89 adds into the accumulator variable sum, and we get the 89 stored there. And the loop iterates a second time, and it just knows that we need to now iterate to the next element in this one-dimensional array. So that number 95 plugs in for next score. We go through the loop again. The 95 gets added in to sum. I'm not sure what that number is. You figure it out. We loop back up to the top. Java knows to plug the next element into next score. So 76 plugs in there. The 76 then gets added into sum, and so on. So this ends. There's nothing tricky here. The sum ends up being the sum of this. The enhanced for loop just knows when to end. There's no need for I less than test scores dot length or something like that, just like there's no need for I++. It just traditionally, typically iterates through in a obvious kind of left to right manner, and it knows when to stop. So the output here is whatever sum is, and that's just whatever the sum of all those numbers is. Exercise 2 is a little tricky. While we have a very short one-dimensional array here, and we have this variable that's equal to 2 in all capital letters, we have a for loop that also uses the loop variable name next score and goes through this array test scores. But each time it iterates and goes through the loop, we check to see if the score is greater than 87 and less than 90. Well, if it is, like in the case 89 is meets that condition, we're adding 2 into next score. Well, you would think that a 91 would overwrite this 89, but you're not allowed to modify elements of this container variable, this one-dimensional array, with actions that are done inside the body of a for each loop. Your compiler might let you try to do this, and you might think it's adding 2 to make that 89 91, but it's not. We'll explain this more fully in class. But basically, iterating through this for each loop and attempting to add 2 to the 89 and the 88 here doesn't work. When we print these positions, 0, 1, and 2, we're getting the original 89, 94, and 88. I'm not going to fill in the answer. You can fill in the answer neatly on your paper. So number 2 is just bad logic. Number 3 is common sense. We have a two-dimensional array. It does work as it's intended to work. We have a two-dimensional array with 9, 8, 7 across the first row, 9, 5, 8 across the second row, and we have 2 rows and 3 columns here looked at in this traditional way. And we have a double-nested set of pair of for each loops. Well, the outer loop sets this variable named row to an array of integers, not just a single int. So the variable row, if I were to trace it carefully on my paper, it's not just the number 6. It's the whole one-dimensional array, which is really position 0 of this array of length 2. All of this plugs in for row on the first pass through the outer for loop of scores. Now we get to the inner for loop, and we need this variable named next score to be accounted for on our Scratch work. And we are plugging in an integer coming out of the one-dimensional array row, so that 6 plugs in there, just like up above with a one-dimensional array in exercise 1. Well, that number 6 plugs in, adds into sum, so the variable sum is now, it went from 0 to 6. And then we cycle back up to the top of the inner for loop, where the next score, 8, adds in for a grand total of 14 so far. And then the 7 adds in here to a 21. And then we've exhausted, we've ended the inner for loop. Well, the code cycles back up to the outer for loop, and the next one-dimensional array that's part of row, of scores I mean, the 958, plugs in for the variable row. And this array is lost, it's overwritten. And now we start all over again with this inner for loop, and the variable next score becomes equal to 9. Okay, I lost track of my tracing there. That was a 687, now it's 9. And the 9 does get added in to sum, so we're up to 30. And it continues. I'm not going to do the rest of the work for you, but the 5 and the 8 both plug in for next score, and they both get added into the running total, which ends up printing out here as your answer. So the double nested for loop treats this as a row and this as a row, and it works quite well. Exercise 4, the situation again is a simple array, two-dimensional array with 2 rows, but we only have one for loop this time. So what the heck's happening? Oh, this line of code is declaring and instantiating a new array with a length of 2, positions 0 and 1, and the name of it is first games. I'm just going to abbreviate FG. And bowler is a variable that starts at 0, and bowler scores is a one-dimensional array that I could keep track of here, BS for bowler scores. And the 191, 182, 173, I'm sorry I'm being sloppy here, that plugs in for bowler scores as a one-dimensional array. And we're taking whatever's in position 0, the 191, and we're plugging it into bowler 0 position of first games. First games 0 position, that 191 plugs in there. And then we plus our bowler variable. We go back up to the top of this loop. The next row gets plugged in to right here. The 209 is in position 0 of this second row here. So the number 209 plugs into square brackets bowler, which is a 1, position of first games. So position 1 there takes on the value 209. And then we're finished. Bowler does technically plus up to 2. And the for loop just knows when to end. It knows when you're out of space here in this array. And we're system out printing something plus something divided by 2.0. Good luck adding that up. Position 0 and position 1 get added up and divided by 2 to create an average, which prints out. Number 5, if you trace this one, you will see that we are doing a search through a two-dimensional array looking for the largest number, max, but we're also trying to find its row and column number. Well, the biggest number with my eyeballs I see is 9. And it's in position, row 1, position 1, I believe is where that 9 would be if you thought of this as a two-dimensional array. Well, this for each loop here with the colon does correctly, oh, actually it's 2 loops. We've got a loop inside of a loop, and we are processing this correctly using a search. And because of the lack of curly brace, oh, I do have curly braces here, notice. It works, and I'll let you trace this one and determine the output by watching the video and reviewing the exercises above. If you can do exercises 1 through 4, you should be able to figure out the answer to this exercise 5. Good luck.